All right, are we all back? All good? All right, let's get started. I'm going to go through this. Some of the other speakers are saying that they weren't as prepared as they could have been. I am completely unprepared. I was working on these slides during the previous talks, so I'm going to go a mile an hour and hope that we line up the amount of time. So yeah, my name's Tim. I've been an iOS addict for way too long. I've been making apps for the iPhone since the iPhone 3G back in 2008, and I've been enjoying every second of it. And today I'd like to talk to you about something I've been working on for the past few months. It's a very old problem that's been on iOS for a long time, and I've been trying to find a solution for it for nearly a decade now, and I've tried many different permutations, but hopefully this is the one that actually works. So I'm going to talk about basically what the problem is in a real-world use case, why this is actually a good thing to implement. Each of the problems encountered to solve this problem, each of the sub-problems, how I came up with a solution for each one. And my goal for today is hopefully, if you learn at least one new thing about iOS you didn't know about today, then I consider that a success. Cool. So apps, they're a thing. Hopefully it's not too high level. Yeah, apps are a thing, and they're the thing that we're all here for. Just to tie it back to the venue that we're at, most apps are the type, like Line, are platform apps, where the experience is on a platform and curated and controlled, and the value is then derived from these platform experiences for users. And that's the most common kind of apps out there, and I think that's where most of us who do iOS as a living work on some kind of platform. But on the flip side, there's another type of app, apps that kind of have zero value on their own, apps like Keynote and GarageBand. Their value is derived by the users actually creating, consuming, and editing files in there. So the experience is different for every single user because the content is, ostensibly, it is a file. It comes from either you create it from the app itself, or you bring it in from your Mac or your other platform computer. So I've been working on a little app for a little while. I was actually kind of drawing parallel. It's kind of similar to Line Manga, actually. I make a DRM-free comic reader called iComics, and last week, get rid of that icon, I actually, a very kind designer in Canada made me a brand new icon, which I really like. So this is now one of the alternate app icons for this thing. The point of this app is, I'm leading this to my friend, my buddy Kushi-san, because I know Kushi-san loves Star Trek. Yay. Right now, the point of iComics is there's lots of places online where you can buy DRM-free comics. DRM-free is becoming a huge thing, which is great. And right now, Humble Bundle is running a Star Trek promotion where if you pay $20, you get like $500 worth of DRM-free comics. So clearly you need an app to be able to consume those comics on your phone, and that's the niche that iComics tries to fill. To get files from your Mac to your iPhone, though, has been the same mechanism for the last 10 years, since the first iPad came out. When Steve announced the very first iPad, this is when the ability to drag files into your iPad from Mac happened. It's called document sharing or file sharing. And I've been working on an implementation to get this working, and here's what it looks like now in iComics. Basically, you have your file that you downloaded from humblebundle.com, you drag it into your iPhone, and then as you can see, the phone will think for a bit, and then the comic will appear. Now, this is like a really easy kind of thing, and you know, it kind of underpins the entire reason for having the app. Like if you can't get files into the app, it's kind of a terrible app to have. But it's a really hard problem because there is no official API to detect when files come in. Like Apple has never made one. There's one on Mac, it's called FS Events, but there's not one on iOS. So the trick is, how do you implement a mechanism that you can your app can go like, oh, hang on, the user just dragged in a file. I should probably wait till that file finishes copying and then decompress it and get the thumbnail out and start consuming it. But there is nothing official out there. So I actually made my own from scratch. It took 8 months of research, maybe 4 months of planning, and 2 months of just straight up like head-banging coding. And I'll show it to you now, basically what it looks like. So let me come back out. Jeff spoiled the surprise. It is regrettably Objective-C, but I'll show you. That's okay, because it works in Swift. Here's basically an example. Hopefully it'll work. So a feature in iOS 11 was you can now access the bucket, the sandbox for every single app that gives exposes this API via the Files app. So this is the Files app here. So as you can see, this is just raw straight up. These are the files on the hard drive. Batteries are going dead. And this is my little observer. So basically, this is just a flat. Do you want me to just use the running new batteries? This is just a flat table view, but with a very special data source attached. And basically, what I want to happen is if the user starts just touching files in the Files app, like these apps are both open at the same time, what you would hope is the state of your table view reflecting your file system should also match what's in the Files app. So things like if you rename this file, we'll call it like file 1-1, hopefully. Yep, as you can see, it updated here, so the table view refreshed. Or we could do something crazy like duplicate it, and we'll get a duplicate appearing. Or we could do something crazy, the drag and drop API. We could drag this one into a folder like that, and say the folder will update the number of items. It's hard to see in there, but the number of items updated as well. And we can actually go and drag it back out. Oh, arigato. Check. Hey, there we go. See if this works. I need 2 hands for this. Hang on. So you can also like, I think, will this work? No, it won't work. You can actually drag it. You can. I need a real iOS device. It doesn't work on Mac. But you can actually drag files between view controllers by hitting back, like dragging, hitting back, and then letting go. So you can actually move files around. And this library I've been working on, as far as I can tell, is capable of observing every single file change that the user can do to the raw file system, and then reflect that in a series of notifications or blocks or callbacks that then you can act upon. There's a lot of stuff happening here. This is about, you wouldn't believe it, about 4,000 lines of code. And I'll talk about some of the major problems to actually make this happen, to make this work. Like here, one final one. If you delete the file, it'll just disappear from the, it'll get moved to the trash. Okay, this is one thing. On iPad, files don't get deleted. They get moved to a private file called .trash. And that's supposed to hide. It wasn't supposed to show the .trash file, but this is how the file apps work. So you never actually delete files. You can actually go back and restore. And they are living in a special hidden folder called .trash. Cool. So I'll talk about some of the ways I solved this problem. Number one, how? Okay, so I spent like 8 months trying to work out how to do this. This is like a lot of thinking like, well, if I did this would break. If I did this would break. So I'll talk about some of the biggest problems. The first one is you need some kind of callback. Like you can't just constantly poll the hard drive and be like, are there changes yet? Are there changes yet? Are there changes yet? You'll annihilate the battery. So you need some kind of mechanism to receive an alert saying the file system changed. Apple did actually make some sample code. It's very old, like it's been updated for iOS 7. It still requires iOS 6 or higher, which Xcode 11 doesn't even support. And it's, sorry? Okay, and it's the most gnarly combination of C and Objective-C, because it uses a very low-level feature called kernel queues, KQs, a feature of Unix, that all this code will let you point at a folder, and if anything in the folder changes, it'll trigger the block, but it won't tell you what changed, it'll just trigger the block, and there's no arguments. So then you're like, okay, something changed, now I have to go through and figure out what actually changed. So that's not a great way to do it, because it's not really explicit. So suddenly you have to be like really smart to work out, or really brute force, like backtrack to like compare your app state to your disk state and say like, okay, what's different? This must have been what changed. Another thing is they don't work in subdirectories. So like you saw then, I dragged a file into another folder, and my one recognized that, but this one can't handle subfolders. It opens up what's called a file descriptor in C terminology, and then attaches the KQ to that file descriptor. The problem is there's only a finite limit of file descriptors, and in older devices, it's not a big number. It's like, I think on new iOS devices, it's like 1,000. So if you did try and like attach a descriptor to every folder, you could, and it wouldn't be the worst thing you could do, but it'd be pretty bad. But you could easily run up against like a hard system limit straight away. So the straight and narrow of that is the official Apple sample code probably isn't the one you wanted to go with. That being said, this lovely gentleman called Jeff did a presentation at iOS Conf SG last year about a similar file observer library that he used in one of his own projects. And it was very fascinating, and thanks again for doing it, Jeff. And if you want, it's on YouTube, so I recommend watching it. And I do have to give credit to Jeff for this. Going through his code, I found out that Jeff had discovered another mechanism called NS File Presenter. And NS File Presenter is a protocol that was introduced as part of the iCloud sync mechanisms in iOS 5. The idea was, because iCloud Drive could be, or it wasn't even called iCloud Drive yet then, because iCloud could be modifying files in the background, a new mechanism had to be set up to detect when a file you might be looking at is also being touched by another process. And from this, you can actually use this as a way to hook in and receive alerts when something is being modified by another process or by something else. And it's really straightforward code. Here it is in Swift. My real one's in Objective-C, but this is what the Swift looks like. It's just, you just create you create an NS object, apply the protocol, and so you basically just say which queue you want it to happen, want the callbacks to occur on, which URL you're targeting. And there are a variety of delegate callbacks, but the one that most reliably gets called is presented subitem did change. And that'll give you a URL of the file that changed. And this can be any directory level, so it could be the top level all the way down, which is really, really nice because it's way better than KQs. And this is all the code that's necessary. And then once you're done, it goes to a class called NS file coordinator. So you just say add presenter to that, and then you'll start getting callbacks to this object. So that's great. The great thing is it'll give you a URL of what changed. So suddenly you have a hint as to what changed, so you can work out what exactly you need to do after this pact. It triggers all the way down into different child directories, which means it's a lot easier to work with than KQs. You can actually configure the callbacks to happen on background threads, which means you can keep this all off the main thread, which is really good for performance. So all in all, really good. Okay, so the next problem is now we have a mechanism saying a file changed, but how do we work out what the file was? Like, for example, it's not out of this world to have, like, you could have separate folders, each like volume 1, volume 2, volume 3, and having the same file called chapter1.zip in it. So the user could suspend the app and swap these two. You could swap the chapter1 from .zip into another one and back. So file names are completely unreliable. So the fact that we got a URL back doesn't really help us this much because it can't really give us better context as to what file was actually changed. So if only there was a way to uniquely tag each file so we could actually check its ID and work out which file is which. So there is a property in NSURL attributes called system file number, which points to the actual integer value on the Unix file system. Like this is straight down low-level Unix stuff called the inode, which is a unique number that you could use to track these files. But the problem is there's no guarantee that inode won't change if the user duplicates the file or edits the file or renames the file. So this is me going to like the Unix Stack Overflow, trying to work out if this is a reliable way to do it. And the short answer was no, it might change. There's no guarantee of it won't change. So I was like, oh boy, okay, so I need some other way to tag these files from the URL. And there's a really good a blog post on NS Hipster about a feature of the file systems on Mac and iOS called extended file attributes. And this is a really cool thing. What this lets you do is it's not a lot of code. It's like one C function. It lets you actually apply associated metadata with a file. So you can actually from a URL query it for metadata, and you'll get these back. You'll get it back. It looks like this in terminal. So basically what I did was I made my own extended attributes property, and then whenever I imported a file, I would just assign this, if you can see the second last line, assign a UUID string. So now, even if the files have the same name or whatever, we actually have a way of uniquely tagging them. And the great thing about this is it's invisible to the users. Obviously the users can still get to it, but it's not really visible and it doesn't really leave any like cruft in the folders. It assigns this data straight to the file. And this is really good because now we actually have a way of tracking each file in a way that users aren't even aware of. Doesn't actually modify the file, like the modification date or the size doesn't change, which is really good because you kind of don't want to touch the user's file, like modify the user's files if you can help it. Another really cool thing is I saw some other apps using this in really creative ways. Like one of the text editors I've seen on Mac will store the last location where the cursor was when the file was quit. So then the next time you open the text file, it'll put the cursor back to that place. So stuff that you wouldn't cry if you lost it, but stuff that just makes the user experience a little bit nicer, you could put in here, and this will follow the file. This will follow the file wherever it goes. And the nicest thing is that it degrades gracefully. Like if you copy this file to Windows, it'll just go away, and that's fine. So when you bring it back to Mac, you can just regenerate a new one, but it's not going to like corrupt the file or do anything weird in other file systems. So that's good. So now we've got a way to detect when a file changes and a way to uniquely identify a file. The next one is how do you work out what actually happened? Because there's so many things that could happen. Like the user could have dragged in a new file, like I showed with the Star Trek comic, or they could have renamed the file, or they could have not renamed it but just moved it somewhere else. But the reality is the URL changed as a result. They could delete the file. And this is the hardest one. They could duplicate the file, which would duplicate the UUID. So now we have two files with the same ID. So that creates like uncertainty. And the most crazy use case I came up with is they could pause the app, delete the file, add a new file, and then add it to the same name and see if the thing would notice that the file is still there with the same URL, but now it's actually a different file. So the way I did this is I kind of brute forced it. I made a bidirectional dictionary object, a thread-safe one, that has two dictionaries in it. And the first one stores, the first dictionary uses the UUID as a key and a shortened version of the URL as the value, and then the reverse, where it's the shortened URL and the key. And the nice thing about NSURL, I'm assuming it's the same as URL in Swift, is it is hashable. So this actually works as a unique key. So basically what happens is when the app actually starts up and you start this observer for the first time, it will go through every single file in a background operation, scan each one, check if it has a UUID. If it doesn't, it'll make a new UUID. If it does, it'll add it to the dictionary. But at the same time, it checks the dictionary if that UUID exists already, and if it does, that means it's a duplicate file. And so obviously the second file needs to have a new UUID. And so it can actually adjust for duplicate files in this way. And then every time the NS file presenter triggers one that's one of its file to change, it gives you the URL, and then you can take this and compare it against your state in this dictionary. And so if the URL is different, that means it's moved. If the file is no longer on disk, it means it's been deleted. Basically, by having an in-memory graph of where every file should be, and then getting these events, you can then compare what the real state is at the time the event happens, and then work out, kind of like backtrack, what actually changed. And then, so that previous extreme situation, the problem with that one was because the previous file got deleted, the UUID was deleted along with it. So the reason I had that reverse dictionary is to stop, so I didn't have to do like a complete lookup. But the idea is I can query for that previous URL, and if that one already did have a UUID, we can then determine that it was in fact a previous file deleted and then a new file with a different name put into its place. This is why it took a long time. This is like me just walking around my room going like, what if the user did this? Like also, and like I hope this is all the edge cases. I'm sure there's more, but I'm pretty sure this covers the majority of it. And finally, this one was the hardest one. This is the one that's been like the #1 cause of bugs in my app. This is one that's hopefully this is something that other people haven't really had to deal with, but files are big these days and they're getting bigger. So one of those other comics from the Humble Bundle, one called Star Trek: The Best of Klingons, it's a 175 megabyte zip file. So it's why that's the problem is when you drag it into iTunes or drag it onto your iPad, it doesn't copy instantly. Like there is an amount of time, like maybe 5-10 seconds, where it's actually, moving the bytes over to the iPad. But the problem is, basically, you need to wait till the file finishes importing before you try and open it and extract the thumbnail. But the file event saying a file was added happens the instant the thing is dragged across. So you'll get an alert saying a file has been added, but its size is zero megabytes because it hasn't started copying yet. So sorry. So the NS file provider will actually do two events. It'll trigger twice for the file. It'll trigger once to say it started copying. It'll trigger again to say it finished copying. But again, there's no way to kind of like determine. There's no way to figure out what the target file size is. All you can see is that every time you check it, the file size is slightly higher. And up until now, that's how I've been checking. Like I just set a timer every 3 seconds, check the file size again. If it's bigger, that means it's still copying. If it's not bigger, it's probably stopped copying. But that uncertainty is what causes a lot of bugs because sometimes the file system might lag or whatever, and suddenly it does think it's finished copying, but it still hasn't finished copying. So again, this is the hardest problem I've ever had in iOS. It's like, how do you detect if something's copying so you can work out to wait until it's finished copying? And I can't remember which issue it was. I found it on Stack Overflow. I need to track it down, but someone on Stack Overflow found a solution, and it's not as terrible as you think. It works. They basically found out when a file is still copying, the metadata isn't complete yet. So if you query it, if you ask NS File Manager to get its modification date, it'll be the current date. It'll be within like 2 seconds, the current NS date value. Which means, and then once it finishes copying, it'll change to whatever its original modification date was, which is probably at least, it's a comic book, at least 10 seconds ago, before the copy started. So here's a bit of Objective-C, because I could not figure out how to write this in Swift. I'm sorry. I need to practice my Swift. Basically, all this does is, instead of using NS File Manager attributes, it's actually really good to use NSURL get resource value because you can preload that. So this thing does that. It preloads the information, which is really nice because then if you query it, it's a lot faster because it's cached. But as a result, you remove the cached version, you get a new instance of the modification date, And then this last bit of code just checks if the difference between the current date and the modification date is less than 3 seconds, just give it a little bit of overlap, because sometimes it's maybe just under a second. If it's within that, then it's probably still copying. And sometimes, like I found at my sample app, there are cases where if you create the file as a sample file, the modification date is actually within 3 seconds, then it reverts back to my old school way of like setting a timer and checking it again and again until this thing starts reporting that it's not copying. So yeah, so that's all the biggest problems to solve. And as you can see now, if we go back to my sample code, it works, and it is actually smart enough to detect when a 200 megabyte file has finished copying, and if the user renames it or deletes it or duplicates it in the Files app. Because again, the Files app is completely out of your control. Like this is the user just touching files completely out of your own sandbox. But the idea is now there's here's a mechanism that will let you account for that and then adjust your app's logic to match it. So that it's all open source, because if I'm going to spend all this effort, I'm not going to be the only one who can use it. So it's all open source. It's under the MIT license. The name is TO File System Observer. My GitHub is github.com/timoliver. And that's it. Thank you so much for watching. I hope you enjoyed that. Thank you. Now I'm going to do something else in my life. Yep, sure. It's still buggy. Like I was working on this last night and I found a threading issue where, what was it? 2 threads tried to make a UUID for the same file at the same time. I'm like, oh boy. So yeah, there's still a little bit of work to do. It needs a lot more unit testing because all this stuff is like threaded and stuff, but we're getting there. And if anyone wants to file a PR, please do.